powers, and exponents. We're going to be talking about a different type of power and exponents today. The essential question is, why is it helpful to write numbers in different ways? Go ahead and add that to your notes and make sure that you also include the 3 key vocabulary words you need to know, which is power, numbers using an exponent and base, the common factor in a power, and exponent, the number of times the base is used as a factor. Make sure you're adding it to your interactive notebook in Cornell note style fashion. So your title, you'll have your date and name up top, your central question, and then you have your vocab words. Here's an example of what a power, base, and exponent are. So the power is the number itself, the base, and the exponent. So all this together is called a power. The base is the base number. What is the number that gets multiplied over and over again? And the exponent is the little number on the top right that tells you how many times you're going to use that factor. Let's try an example. I want you to write this as a power. So I've got 2 times 2 times 2 times 2 times 2. So I notice all the bases are the same, and there are 5 factors of 2. So instead of writing it out 5 different times, we can make things a little faster and easier by just saying the base of 2 to the 5th power 5 different times. It's also important to know how to read and write powers. So I made a little table for you. Okay, the first part is going to tell you the power, then the words, how you actually say it, and the number of factors that are involved. Let's take a look at the first. 3 to the 1. This is called 3 to the 1st power, and there's only 1 3 there. Next, 3 to the 2nd power, or 3 squared. That's 3 times 3. 3 to the 3rd power, or 3 cubed. 3 times 3 times 3. Now these two are the only ones that have special names, if you will. Everything else is going to be to the 1st power, the 5th power, the 10th power, whatever. But when you have something to the 2nd or 3rd power, we do have a little shortcut. You could just say 3 squared or 3 cubed. 3 to the 4th is just 3 to the 4th power. There's 4 factors of 3. And then I just left one, 3 to the nth power. Just means that however many factors there are, that's what you would plug in there. So if there was 100, you'd say 3 to the 100th power. If there was 1,000, you'd say 3 to the 1,000th power, and so on and so forth. Make sure you're taking the time to write down your examples and how to write and read powers in your notebook. Doesn't have to be perfect, but you have to be able to read that for later use. Okay, so let's try out some problems here. Question is, write an expression, or write each expression using exponents. Okay, so basically I have this long line of things that are being multiplied, and I want to simplify it by using exponents. So I take a look at my examples. Here I have negative 2 times negative 2 times negative 2, all the same base, and 3 times 3 times 3 times 3. That means I have 3 factors of negative 2 and 4 factors of 3. So we write that as negative 2 in parentheses to the 3rd power. That means I'm taking negative 2 and I'm timesing itself by itself 3 times. And then you got 3 to the 4th power. I can't go any further. They have different bases, so that's my final answer there. Time for a second example. Okay, A times B times B times B times B times B. That means I have 2 factors of A and 5 factors of B. So my simplified version of this expression would be A squared, or A to the 2nd power, that's this part, times B to the 5th power. I can't go any further because the bases are not the same, so I cannot add the exponents. You just leave it like that. Okay, here's another example. This one I try to fool you because I put M times N times N, and then another M. Let's see if you can figure it out. If you did it right, you should have M to the 3rd and N squared. Those two are being multiplied with each other, but we can't go any further because the bases are different. How did I get m to the third? Well, I have 1, 2, 3 m's. Even though they're not all next to each other, we can place them next to each other and get m to the third. N times n, that's 2 factors of n, and that's how that's written. All right, let's challenge ourselves. Let's throw in a fraction. Why not? Okay, so 2/5 to the third power. That means the base is 2/5. It's going to be multiplied by itself 3 different times. It would look like this: 2/5 times 2/5 times 2/5. And if you remember how to multiply fractions, it's just multiply the top, the numerators, 2 times 2 times 2, which is 8, and then multiply the denominators, 5 times 5 times 5, which is 125. Okay, let's try to evaluate. This is -2 to the 6th power. So if we had to expand that out and write it out, what do you think it'd look like? Look something like this: -2 times -2 times -2 times -2 times -2 times -2. Basically, there's 6 -2's being multiplied with each other. So what I would do is I'd write it all out and then just piece by piece simplify it. So like -2 and -2 is 4, another -2 and -2 is 4, and the last -2 and -2 is 4. And then I can just multiply those three together and get 64. Okay, so we're going to try one more type of problem that you might see. It says to evaluate the expression if A is 3 and B is 5. So we're going to replace the A's with 3's and the B's with 5's. So it's called substitution when you replace a letter with a number. So if A is equal to 3, A squared now turns into 3 squared. And if B is equal to 5, then B cubed turns into 5 cubed. Now remember, 3 squared, all that really means is 3 times 3. And 5 cubed just means 5 times 5 times 5. So I can do 3 squared, that's 3 times 3 is 9. 5 times 5 times 5, 125. And then my last step is to add it together, 134. Try one more. A minus B, and then square it. Remember, if A is 3 and B is 5, that means I substitute the A with 3 and the B with 5. 3 minus 5 is -2. And then finally I square that. -2 times -2, which is 4. And that would be your final answer. Feel free to ask as many questions as you like during class.